All right, welcome back. So I'm about to give you two problems for you to solve. Then I'll have take a breath and give you a chance to pause it and solve it. But what we have here, just in case it's not showing up particularly well, is we have a 4 kilogram mass here going to the right at 10 meters per second. It is pursuing another another vehicle or object over here, which is 8 kilograms going at 1 meter per second, also to the right. So the first problem here, they are both going to the right. In the second problem, I have a 3 kilogram mass going to the right at 4 meters per second, and a 1 kilogram mass going to the left at 6 meters per second. And so the question is, in a perfectly inelastic collision for problem 1 and for problem 2, for problem 1 and problem 2, perfectly inelastic, in other words, they stick together, what is the final velocity? And then for each problem, in a perfectly elastic collision, in other words, kinetic energy is conserved as well as, and they bounce off each other. In a perfectly elastic collision, what are the velocities after the collision? Now for the perfectly elastic problem, there are 3 techniques that I've done in other videos. Pick a technique and learn it. I'm not specifying which technique you should use. I know there's the technique that I personally prefer because I find it easiest, but that is for me. However, you pick out the technique that works for you and learn how to do that technique. Because I will tell you, on the test, there will be a perfectly inelastic collision problem and a perfectly elastic collision problem. I guarantee it. On that last test, there will be one of each. They might be the same problem or there might be separate problems, but or same initial setup or different initial setups, but there will be a perfectly elastic collision, there will be a perfectly inelastic collision, so this is like test prep right here. I'm going to take a deep breath here and then I'm going to come back with the answer, so pause it or stop it, whatever you need to do in order to work through the problems. I'm just giving solutions here, I'm not going through how to work it, because especially for the second one, that's 3 different techniques. If you run into trouble, try one of the other techniques. Probably the biggest issues that people will have is recognize if to the right is positive, then both of these initial velocities are positive. Down here, if to the right is positive, this velocity here is positive, this one here is negative. That's probably where I see the biggest mistakes. Second biggest mistakes is just careless math errors. So just watch out for that as well. All right, so I'm going to take a pause. Let you just take in the glory, assuming that you can see it on the video. All right, assuming that you've unpaused it now, welcome back. The answers are, for this one right here, answer to A is positive 4 meters per second. And the answer for A for down here is positive 1.5 meters per second. The answer for B, here, the velocity of the 4 kilogram mass final is negative 2 meters per second, and the velocity of the 8 kilogram mass final is 7 meters per second. Yes, I made the answers so they came out as nice integers here, just to make life a little bit simpler for you. And then down here, B, the velocity of the 3 kilogram final is negative 1 meter per second, and the velocity of the 1 kilogram final, this one right here, is 9 meters per second. So those are the answers. Hopefully you got those, and if not, please take the time to try to figure out where your mistake was. If you're still struggling, you can always take a snapshot and send it to me or type it out longhand in an email. But please make sure you know how to do these problems. Again, there will be a test on the final. In case I had not mentioned it 100 times already, I will eventually mention it 100 times. So it feels like it at least. So those are 2 sample problems for you to work on. Enjoy! Hey, don't forget, it's physics. You should be rejoicing.